All right, welcome to lesson 1.5 about composition of functions. I'm just going to start you off with a pretty basic one, just go through the process. We're really going to focus on domain, and I'll get into that here in a few minutes. But let's just run through the main idea. You've got a function f of x here, and you've also got a second function g of x. And we're going to compose them, which basically means plug one into the other. So first up, notation. This is the way you say this is g of f of x. It's probably easier to write it in this format, and that's what I recommend to you. Textbooks sometimes will give it in this format. That's what it means. It's much easier to work out of this format because you just take the inside function and do direct substitution. So we'll be looking at g of x squared plus 3x. And we've already done this a little bit with the difference quotient, so it's just kind of building off that same idea. You've got something to plug into g. Here is your g function, so 2 times x squared plus 3x. So just be careful distributing, make sure you do everything correctly. You're going to have 2x squared plus 6x plus 3, and that'll do it. That's your g of f function. For f of g, again, I'm going to rewrite it as f of g of x this way. So again, f of g of x. So we rewrite it that way. This one's going to be a little more involving once we get to the expansion process, but let's make sure we plug it in correctly. So I'm taking 2x plus 3, which is the g function, and I'm plugging it into x. So 2x plus 3, always just put it in parentheses when you make a substitution for an x. It makes it a lot easier. So that quantity is going to be squared plus 3 times the same thing, 2x plus 3. All right. There's a couple ways you can go about this, but let me just give you the answer and make sure that you have a method to get to the right result. There's a shortcut, or you can do FOIL, but keep in mind you're squaring this binomial. 4 multiplications have to happen. So this part becomes 4x squared. The shortcut I prefer because it works when you're squaring 2x times 3 times 2. So we're going to add 12x there. And then plus 9 at the end. All right, distribute here, so plus 6x plus 9. And we'll wrap it up 4x squared plus 18x plus 18. On this example, we're going to up our game a little bit because we're going to really focus on domain at this level. You're starting to see throughout the chapter the domain is critical to understanding how a function is going to behave. You've got to know where it exists. So we've got f of x is x squared, g of x is square root of x minus 2, and I want to find f of g of x. So before I go too deep into this, I want to think about the domains for each function. We know f of x, we know x squared is a parabola, so that's going to be fine everywhere. All real numbers, you can square any number, any real number, and you get a real number out. That's the way to think about it. On here, so we got square root of x minus 2. Again, the way we want to think about this, we are graphing in a real coordinate plane. X and y, 2 dimensions, both real numbers. That doesn't allow for any complex numbers to exist because they actually exist outside that dimension. But anyway, they can't be on the graph, so we don't include them. So x minus 2, that quantity has to be greater than or equal to 0. So your domain for this function, x values that are greater than or equal to 2. So you got to really pay attention to what is being plugged into what other function. So this innermost function, that's the one you really got to pay close attention to in the domain. I'm not saying there'll never be an issue here, but you really got to be careful when you're plugging something into a function. It's got a domain restriction. There's usually going to be a domain restriction at the end that you may not expect or you might miss. So let's just kind of keep that in the back of our mind. We'll go through and just compose this like we normally would. So f of square root of x minus 2. All right, we'll plug that in here. That's going to mean square root of x minus 2 gets squared. And square and square root, it undoes it. It's an inverse operation. However you want to think about that, your result is x minus 2. Again, domain is our focus here. So it appears that we've got a line, just x minus 2, and that's our result. And if that was the case, it'd be all real numbers. But we had a domain restriction. And that domain restriction is going to carry through. So I'm going to make a note here where x is greater than or equal to 2. So that's our final result. Let me give you some ways to kind of think about this and clarify what's going on. So let's think about a table. Let's suppose that I tried something that was smaller than 2, like 0. All right, and I'm going to plug that into my g function. So our g function was x squared root of x minus 2. So if I put in 0 for x, what I'm going to end up with, sorry, that was supposed to be an x right there. If I put a 0 in for x, then what I'm going to get out is the square root of negative 2, which is not real. So for now, I'm just going to say it's not a real number. No result. So if I don't have a result to plug into my f function, I can't go any further. I'm done. I can't, that's not in my domain. So that point will never carry over into your line that you get at the end. So let me do it in Desmos just so you can see the graphs and how they come together. So let's start with the g function. There's your square root of x minus 2. F shouldn't be too alarming, it's a parabola. So what we're going to do, we're going to take all these y values we get, and then we're going to plug them in as x values and see what happens when you square them. That's how you get your result. Well, the first x value I can plug in is 2. There are no x values smaller than 2 that I'm able to plug in. So again, if you think about a chart, start at 2, plug it in, plug in 3, plug in 4, and so on. See what happens. So here's what your final result looks like. And Desmos is aware of what's going on, and the way it's calculating this, it accounts for the fact that, oh wait, this isn't a real result. I can't plug it into F. So you can use Desmos to check your work as you're going, as you're getting used to this process. Example 3 is pretty similar initially, so I'm going to go in here and get the domains for these. We're taking the square root of x, so we just know that that has to be greater than or equal to 0. This one's a parabola, so all real numbers are going to work there. No issues, just a normal parabola. So we'll start with f of g of x, and I really just kind of want to show you something that you might make a mistake with the algebra at this stage of the game. We're still pretty early in the year trying to get up to speed with all these solving processes. So just run through this, check it out. Let's plug in the g function into f, so x squared plus 1. And that just means that that's going to get squared. So x squared plus 1 quantity squared. So it may be tempting to say, oh, x squared, we're taking the square root, let's just make that an x. But that won't work, so we can't do that. And this is actually as far as you can take it. All right, g of f of x, it's got a little bit of an interesting result. So let's go ahead and kind of dive into it. We've already looked at our domains. The innermost function here, f of x, it does have a domain restriction. So when that's happening, I'm keeping that in the back of my mind. When I get towards the end, I'm probably going to have a domain restriction that may not be obvious, but I got to make sure I check for it. So I'm going to go ahead and plug in f of x to g. So we'll go ahead and write it in this format. This is the recommended format just so you don't make any mistakes. Shortcuts can lead to you leaving details out, so be careful taking shortcuts. So I'm going to rewrite this g of square root of x. Now I'm going to plug square root of x into x and g functions. So in parentheses, square root of x, because it replaced an x, squared plus 1. All right, so not a whole lot of work to show. Square root of x squared is just x, and I get x plus 1. Again, this is another situation where it feels like it's a line, wouldn't have any domain restrictions, but we said in the beginning that if x is less than 0, if x is greater than or equal to 0, that's the domain, so we can't have anything less than 0 be in this domain. So that's got to carry through. I want to talk about this because some of you may be thinking, wait a second, what if x is, say, negative 4? So then the square root of negative 4, now we haven't covered this yet, but you've covered it at some point in your life, so you probably know this. It's plus or minus 2i. And when you take plus or minus 2i and you square it, I'm just going to leave it plus or minus because regardless of whether it's a positive or a negative, when I square it, it's going to have the same result. That's going to go back to being -4, which would have a result of -3. Seems logical, I agree. So let's go to Desmos, because it always seems to know what's going on, right? So here's f and g. It's pretty similar to the last example of parabola and a square root. And here's g of f. Let me take those other ones away just so you can see it. So there's our line, but Desmos seems to be agreeing that it's only x values that are bigger than 0. It's kind of strange, I know. So here's the detail you got to think about. It's a topic called closure. So if I add two whole numbers, like 2 plus 3, I get 5 out, which is also a whole number. Closure is really what leads to our other operations. Let's suppose if whole numbers are the whole world that I know that exists, numbers that I can count by including 0. Well, let's suppose I do 2 minus 5. I don't have any more numbers, so I have to invent a new number set to allow that to happen. And that's how you get out of closure. 2 minus 5, both of those are whole numbers, but the result is an integer. So that's what I'm talking about when I say closure. We'll talk about that sometimes in here. So keep in mind, here's why this can't work. We're looking at a real XY coordinate plane, real numbers, not complex. Complex numbers actually exist in a fourth dimensional space, and that's as much as I'm going to say about it right now, but it's definitely, they don't exist in our XY coordinate real number plane. And that's where we have an issue here, because in order to make -4 work, yes, if we are existing in a fourth dimensional space, it would equal -3, but we're not considering complex numbers in this space, in this plane. So that's why we can't be jumping into complex numbers and then coming back if we're looking at it this way. So that's the way you want to approach this. We're strictly doing real numbers right now because we're only in the real XY coordinate plane. This last example is pretty easy. It's just maybe uncomfortable at first. Just got to get used to how it's, what we're doing and how to go through it. You've got a parabola on G, but f is sort of a, I guess you'd call it a non-standard function. This is a function. It passes the vertical line test. It's just not something like x plus 2 or x squared plus 5 or something simple that we're used to graphing, but it's still a function. All right? So we're going to find f of g of 6. We're going to work it out as if it was any other function. It's just we have to use the points on the graphs to get our answer. So I'll start by doing g of 6, because I need to know what that equals to know what to plug in here. Well, g of 6, here's g, here's 6 as an x value. We're going to get 5 out for our y. Now that I know what g of 6 is, I'm going to replace g of 6 with 5. So I'm going to find f of 5. All right, well, here's our f function. Here's 5. The result is 7. So f of g of 6, the result is 7. And if I want to find g of f of 4, this time I'm starting on the f function. So I like to kind of break it down like this again. So f of 4, all right, let me go up and look at my graph. 4 maps to 3. So now I'm going to be finding g of 3 when I make that substitution. So I look at my g function. 3 maps to 2. 3 on the x maps 2 on the y. So that'll be my final answer.